Welcome to Ask and Learn.
We are given a recurrence relation, and we are asked to find all solutions of the recurrence relation. The recurrence relation is an equals -5 an minus 1 minus 6 an minus 2 plus 42 times 4 to the n. This is a linear non-homogeneous recurrence relation. The associated linear homogeneous recurrence relation is an equals -5 an minus 1 minus 6 an minus 2, and the characteristic equation is r squared plus 5r plus 6 equals 0. This can be factored as r plus 2 times r plus 3 equals 0. And so we have the characteristic roots are r equals -2 and r equals -3. So we have that the general solution to the associated linear homogeneous equation is going to be alpha 1 times -2 to the n plus alpha 2 times -3 to the n for some constants alpha 1 and alpha 2. And we have that in the non-homogeneous equation f of n is equal to 42 times 4 to the n. 42 is a polynomial of degree 0, and we have that 4 is not a characteristic root. So the general form for a particular solution is going to be p0 times 4 to the n and in order to find the value of p0, plug in the particular equation back into the non-homogeneous equation. So on the left-hand side we have p0 times 4 to the n is equal to, on the right-hand side we have -5 p0 times 4 to the n minus 1 minus 6 p0 times 4 to the n minus 2 plus 42 times 4 to the n. And if we divide both sides by 4 to the n minus 2, we get 16 p0 is equal to -5 times 4, which is -20 p0 minus 6 p0 plus 42 times 16 . And so we have that 16 plus 26 is 16 plus 20 is 36 plus 6 is 42. P0 equals 42 times 16. So we get that P0 is equal to 16. So that the particular solution is simply 16 times 4 to the n. This is the same as 4 to the n plus 2. And we have that all solutions have the form an, which is equal to the particular solution plus the general solution to the homogeneous equation. And this is equal to alpha 1 times -2 to the n plus alpha 2 times -3 to the n plus 4 to the n plus 2 In part B, we're asked to find the solution of the recurrence relation from part A with initial values a1 equals 56 and a2 equals 278. From part A, we have the general solution, and so if a1 is 56, this means that 56 is going to be equal to alpha 1 times negative 2, so negative 2 alpha 1 minus 3 alpha 2 plus 4 to the third power, which is 64, and we have that since a2 is 278, we have 278 is equal to negative 2 squared is 4a1 plus 9 alpha 2 plus 4 to the fourth power. This is going to be 16 times 16. Which is the same as 64 times 4, which is 240 plus 16, which is 256. We can rewrite this system as first equation, we can add 2 alpha 1 plus 3 alpha 2 to both sides, and then subtract 56, so we get this is equal to 8. And for the second equation, we have that 4 alpha 1 plus 9 alpha 2 is equal to 278 minus 256, the same as 78 minus 56, which is going to be 22. And to solve this system of equations, subtract twice the first equation from the second equation. And so I get 9 alpha 2 minus 6 alpha 2 is 3 alpha 2 is equal to 22 minus 16, which is 6. So that alpha 2 is equal to 2. And for back substitution, alpha 1 is equal to 1/2 of 8 minus 3 alpha 2, which is equal to 1/2 of 8 minus 6, which is 1. And so we have that our solution, an, is 1 times negative 2 to the n plus 2 times negative 3 to the n plus 4 to the n plus 2.